free to use very soon. Even though it hasn't officially been released just yet, you can still sign up on patreon.com/thecherno and get access to all of the source code, all of the development repository, all of that stuff, and actually start using it immediately, which is what this person here has done. I have been getting a lot of requests from you guys to actually make videos showing how to make games in Hazel, but I'm more or less waiting until that free, full, stable version gets released, because first of all, that's obviously going to greatly increase the target audience size for those videos, but then we're also getting to a place where Hazel will be a lot more stable, a lot more usable, and I'm not going to have these obsolete videos, these outdated videos on the channel that I'm going to have to update and remake anyway with the new version. So if you do have access to Hazel, and I will leave a link to this repository in the description below in case you want to check it out. Again, 2024.1 was the version of the engine that Neff has said he is using, so that's what I've got over here, checked out, ready to go. Without further ado, let's dive into the repository and take a look at what we have here. So first of all, a couple things I'm noticing just by looking at this repository is there is no README. Again, I say this pretty much every single time that there is no README. There should be a README that just even shows like a screenshot of this. I mean, presentation is really important, but also maybe some build instructions, just like some information about the game, like just really simple stuff. Just have some information about what this project even is in the first place, how to get it up and running, and show it off in a screenshot. It would have been nice to actually see the Ludum Dare submission page, assuming that was a thing, like assuming this person actually did submit it as like a Ludum Dare game, and also was it built using the runtime or not, in which case are there pre-built binaries that I can just play, or was that something that Neff didn't know how to do? Like, I don't know. But that's step one. Step two is resources scripts intermediates. As the name implies, none of this stuff has to be committed. These are just intermediates. They're not even binaries or anything. So definitely don't commit this. And also I'm suspecting in assets and probably scripts, binaries and intermediates debug. These also can just be added to the git ignore along with this obj directory, which is also like intermediate. Source is like the only thing you need here. Oh, it looks like there's quite a bit of source here. That's nice. It's not just like, cause I don't know what to expect from this. This could be just like a really tiny game. We'll see. Lots of different assets. It seems. Is there stuff in like models and meshes? Yeah, it looks like a decent amount of stuff. There's a bunch of FBXs and GLBs. So we'll have a look at this inside Hazel and see what we can do. Now, as always, you guys can submit your project in for review by emailing it to chernoreview@gmail.com. That email address and some instructions will be in the description below. However, if you can't get me to review your code, then you should get CodeRabbit, the sponsor of this video, to review your code instead. CodeRabbit gives your code AI-driven contextual feedback no matter what language. This makes it so. Again, this is 2020. My link will be in the description below. Huge thank you to CodeRabbit for sponsoring this video. Okay, so Hazelnut, which is the editor, I'm going to build in release. That's all I'm going to do. And again, this is 2024.1, not like the current up-to-date dev repository, which is not expected to probably work with any of this stuff. Over here on disk, I've checked out the repository. We have the full solution file, so I'm going to open that as well. And this is the hproj file. This is like the Hazel project file that we now need to load inside Hazel. So let's just not show that again. So file, open project. We'll go to this path and we will open up the full.hproj and hopefully this opens. There we go. We've got something. Oh, this is interesting. I haven't looked at this project before, so we're going to have to take a look and hopefully it's going to be straightforward because I don't know, everyone sets up their games a little bit differently. Obviously, Hazel's a very flexible engine as well. So it's going to be interesting to see how this is put together. Space to play. Got a bunch of entities over here. All right. And then we've got obviously the solution file. So debug release doesn't really matter for these C# scripts. I'm just going to build these and there we go. Everything's built. Hazel will actually build these scripts for you, but I just wanted to make sure that everything compiles. And then we've got all of the files over here. So I'm guessing the first thing I should do is probably try and play the game. I have no idea how to actually play it. So if we hit play and then I guess we press space to play, I guess we'll fade into something and then we're falling. Okay. I think I'm controlling the leaf. Oh, is that supposed to be wind? Okay. So I can, light fades from us, press space to replay. So I think W and, sorry, A and D, so like the WSD keys, but I don't know if W and S does anything, no. So A and D looks like it moves the leaf, I guess. I don't know what my objective is at all. It would be really good to have some instructions on like how to actually play this game and you know what the objective is and what the controls are. Are those all the controls? I can't see where I'm going anymore. Is that because I didn't pick up enough light? I'm guessing I'm supposed to pick up the light phase from us all. So do I lose if I run out of light? And I guess these are the light things that I can, okay. And then that's just like fading over time, is it? So I'm trying to pick up these lights. Okay, that makes me brighter. No way I can get there with the wind. There's no light for me to pick up. Oh, here we go. Oh, Oh, but if I hit that, do I lose? Okay, I'm gonna quickly have a look at the source code because this doesn't really do a good job of explaining how to play the game. So let's have a look at, I'm just gonna do a search for input and see, oh, space does something. What is the space? Oh, that's for the main menu. Okay, A and D, yes. Oh, look, there's a if input is mouse button pressed, mouse button right, trigger the dash. Okay, in the relative direction of the mouse. So you can dash with the right mouse button. Okay. And then how do I see? This is a bit ridiculous, obviously, the fact that I have to like look through the source code to figure out how to play. But what I am interested in as well is how I lose. So I'm guessing game manager. Let's have a look. The code is actually pretty clean so far. Like I'm, terminate game. So game over equals true. M lights, and so when does this get? There's one reference to this in here, and that's if distance to player between what? The player and this obstacle object is less than the detection radius, then we end the game. Oh, detect if we hit the player. So I'm not allowed to hit obstacles, apparently. Maybe that was the issue. Okay, let's try, oh, whoops, doesn't matter. Let's try play again, and then I'm going to, I guess I can dash. Oh, that's a dash with the right mouse button. So if I hit that, I lose. Yeah, okay. So I can't hit obstacles. I don't think light matters at all. It's just that obviously I can't see if there's, oh no, I'm definitely gonna lose. Oh. I don't think light matters. I think I just can't see, obviously, if there's no light. So therefore, how am I going to dodge the obstacles? For example, here. Why is there no more light spawning? I really have to pick it up. Maybe it stops spawning if you miss it. And it looks like with the dash, I didn't actually hit anything there, I don't think. What are can I see the physics colliders? I'm going to go to the viewport settings up here and actually show, all the physics colliders. Okay, so that's the leaf collider. And there's all these, I wonder if they're just, I don't know what they are. I want to see if the colliders are like super big or something. That's got a sphere collider on it. Can't even really see that. Never mind. Okay, whatever. That's the game. We're a falling leaf. We collect light. There's wind and there's this particle system, I guess. And you're just trying to survive, I guess, for as long as possible. But there's no score or anything. So fairly primitive game, of course. Not too much going on here. Definitely could be refined a lot more. But hey, it's made in Hazel, so I can't really be too harsh on it now, can I? We got this like very interesting looking, what is this? Very interesting looking main menu setup. And I guess it's like, these are trees or something, and then we kind of jump in the tunnel or whatever, and then we're falling into the thing. So that's interesting. So I'm guessing we've got two scenes over here. If we have a look at the scenes, we've got the menu and then we've got main. So if we look at the main scene, this is the main scene. Okay, so this is what it looks like. So we've got the leaf, we've got a light, we've got this, and then I'm guessing these like walls. There's only 2 walls here. I'm not sure why it's not highlighting them, like to show what's selected, because it shows the leaf, but this wall, it's not highlighting the mesh. I don't know if that's because it's like really big, or that's very interesting. Weird. Okay, and then this environment tray, whatever that is, has a bunch of lower bounds and upper bounds. That could just be, let me just show. So with the physics colliders, I can also show just the selected entity. So that might help if we actually want to see if they have bounds. But here's well walls. These walls are different, I guess. They're also kind of at the origin though. They're these ones. Oh, hang on. Static. It's not visible. I'm a clown. It's not visible. So I guess this is just being used as like a collider, but it's got a box collider on it. So this is a bit, you don't need the static mesh here at all. I mean, it's not going to render, so it's not using up too much performance, but still having this is a bit redundant, because if you were using it as a mesh collider, then obviously that would kind of make sense, but you don't actually need the static mesh component for that. Because if you use a mesh collider in Hazel, then you can just, usually you can specify which mesh you want to act as a collider, but maybe not though, because no meshes are coming up here, which makes me think that it's a different asset type. But anyway, obviously, yeah, static mesh is just like for rendering, and then box collider, if you have a box collider, then you don't need the static mesh on it. Now, if you have a collider with no rigid body, it's going to be a static rigid body by default when it gets, like when the scene actually starts. But otherwise, if you want to override parameters, then you can also add a rigid body and configure things such as like what physics layer you want it to be on and stuff like that. Okay, so that's what those walls are. And then environment, well walls are these things. And then we've got like these wall segments, which I'm guessing kind of the script will probably either move them down or spawn more or do something as we drift down. Now for the actual player, so it's got a box collider on it, it looks like. It's got a dynamic rigid body, so it's using Hazel's physics system, as you probably would expect, to make it fall downwards. We've got some, what does this look like? like mass 1. Yeah, so like, I don't know. Obviously, this is very subjective. You can tweak physics parameters however you like. This is basically like in kilograms. So 1 kilogram is a little bit heavy for the leaf. So if you want it to be a bit more floaty, maybe you could make it way less. So when you're making physics for a game, especially a very abstract arcadey game like this, it's not really like the goal isn't to make it like a simulation necessarily. It's just whatever feels good and whatever is good for gameplay effectively. So it doesn't really matter like that this weighs 1 kilogram. If you kind of control your forces in such a way that that feels good to you, then these numbers don't really matter. They're just numbers. What you're trying to do is obviously create like a good feel, and that takes a lot of time and a lot of expertise and a lot of like testing to get right. And that's obviously very difficult to do in a game jam. So that's why a lot of game jam games end up not feeling very polished, because that polish stage can take a significant amount of time. And, you know, in a professional game studio, you'd get... So we are preparing to release Hazel, my game engine, for free very soon. And part of that roadmap is basic multiplayer. One of the 2 things that I'm currently working on. The other is the new Renderer 2025, which you may have seen me live stream for like the past month. By the way, all live stream VODs are uploaded to my other channel called Cherno Unplugged. I'll leave a link to it in the description below, so you can take a look at all the work that's going into that project entirely on that channel and live on Twitch. Anyway, the other big thing that I'm basically simultaneously kind of working on is basic multiplayer. Now, we started working on this the second half of last year, and then hey, what's up guys? My name is Cherno. Welcome back to another Cherno live stream. Because again, when you're doing graphics passes, it makes sense to kind of submit stuff to like a render command queue, but meaning like a different thread to the render thread, submitting it to the render thread. But here, because we have the transfer queue anyway, and also there's not that much work to do here, we can just do it on the main thread, I guess, or on the calling thread, really. So we would basically do this, and then the right texture is obviously what we're trying to do here. So in order to do that, we would kind of do like, I guess, get active and then write texture. So we can do that there, and then we do RT end, and then we have to do submit, RT submit. And that's it. So that replaces all of this code. So it kind of looks like this. And again, what happens is if we what happens here is that if we sorry, what was I saying? Yeah, if this is, I don't know what I was saying, but this should be fine. And we just have to make sure that we find all the other instances of that. And kind of took a little bit of a break because I wanted to focus on Renderer 2025, and now we're getting back into it. The way that we left it last time was we had Genesis, this like game that was the first game that I ever made, and then I'm remaking it in 3D now in Hazel, and it's also an MMO. Why not? That is now more or less running multiplayer. In fact, more work has actually happened on Genesis 3D behind the scenes because Jim, aka Zero X, has been working on animation for networking. But anyway, that's besides the point. The point is we are getting back into multiplayer. We're getting back into Genesis 3D, and I thought that a good way to kind of revive this project would be to share with you how exactly multiplayer works in Hazel and what my plans are for it. Is basically implemented to the degree that I want it to be when we ship this first version of Hazel. I think it's more about refinement now. But here's the thing. As I show you all of this and I walk you through how everything works and the kind of experience that I've designed, I want you to think about it and give me some feedback. I have only ever professionally worked at EA, like on Frostbite, Osiris, like engines there. Obviously at that scale, things are very different, and I haven't really made any kind of multiplayer indie game or anything myself. My goal with Hazel is to try and keep things as simple as possible, which you're probably going to see in this like multiplayer design and implementation. So for those of you who might have some experience or have tried to make multiplayer games in other engines such as Unity, Godot, Unreal, maybe you'll have some opinions or some weird things that I'm doing here that are going to make it more difficult for you to potentially use Hazel in the future to make some sort of networked or multiplayer game. So without further ado, let's take a look at Hazel and how this whole multiplayer thing works. I think the first thing I'll show you is this is Genesis inside Hazelnut, Hazel's editor. And then I've also got in VS Code here, I've connected to an actual server. This is hosting a server. And I have this run server command, which is going to run the Hazel headless server. So this is also Hazel compiled on Linux and then uploaded like to this hosting a server. If I go ahead and run the server, you can see it's going to start this scene called main, which is this scene inside Hazel that we are currently looking at. And then if I flip flip back into Hazel, with that now running, I can hit play, and you can see it's going to actually connect to the server. The reason I know it's connected is because, first of all, the time over here is counting down, and the server is the authority for that time. We also have this object here, which is like a little test physics object that is entirely contained within the server. So the reason we're seeing this now is because the client is receiving data from the server and telling it to actually like render this cube at a position, but the actual physics simulation is happening. Well, we can't replay it because the physics simulation has already happened. But if I disconnect and reconnect, you can see how like another female spawns over here, and their positions are also entirely dictated by the server. But my point with the cube was just that when the server starts, there's like a physics simulation that plays, it drops out of the sky, lands on this plane, and that is entirely simulated on the server just as a little test. But anyway, these females moving around here, these female entities, which are the pink girls here, they are entirely controlled by the server, and that logic is actually written in C#, much like you would just write client-side code for a game in Hazel. So that's really nice. It's not like custom or anything, it's actually all within this project. Now you can see here they're not actually animating, and that's because we don't have Jim's networked animation code within this branch over here, but that is in fact working. Maybe I'll show some video on the screen right about now. Anyway, the other thing I can do with this still running is I can start an instance of the runtime just to get another instance of Hazel up and running. So I believe we have a build of Genesis for the runtime. So if I just try and, sorry, compiled, if I just try and run the runtime while the editor is also running, then we should be able to connect. Oh yeah, we don't have textures here for some reason because they're disabled. But if we have a look at this, we should actually be able to find each other. So where's the other player? So you can see there's only one other like green player. So if we run to him over here, as I run to him, we should be able to see it inside the Hazel client. And you can see I'm kind of walking around. And if I switch to this one and walk around, we're going to see it move inside the editor. So there you go. That's networking working. And at the moment, you can have like as many of these clients as you want. And obviously like the time is all synchronized. I don't think I'm laying it out properly here. That's why it's being cut off. And also I think when the seconds get down to 0, like 1 minute and 6 seconds, it's not displayed correctly. Anyway, none of that matters. This is in development. Anyway, the point is we are seeing obviously real-time multiplayer happening over here. So now let's discuss how it's actually implemented both client side and server side, and also my idea for what it would look like to actually make a multiplayer game such as this one in Hazel. So obviously you can't really have multiplayer without a server. And over here we are running on a Hostinger VPS. Now Hostinger have actually been nice enough to sponsor this video as well as all of like these multiplayer networking projects that we've been working on for Hazel. And my experience with using Hostinger servers for both to get an additional 10% off for yearly plans. Huge thank you as always to Hostinger for providing us with some extra structure, I guess, that we have for networking inside Hazel. It's basically all contained within this module called HazelNet. There is some code outside of that, such as like the C# script glue, so that we can call some of these functions and use this functionality from C#, and it kind of links back into C++. But the actual bulk of everything is inside HazelNet. And you can see here, there's like 6 files here. It's very, very minimal. It's very small. It's very simple. That's the keyword of this whole project. So we have a client, we have a server, and then we just have some utilities, right? To like resolve, I think we've got like one utility basically. Well, actually this will check if it's a valid IP address, and this will resolve a domain name. So that aside, we have this client and server architecture. Now the core of all this networking functionality starts with this library called Game Networking Sockets by Valve. And so because it's by Valve, you can expect that it's quite well suited to video games. I'll leave a link to this in the description below. It's open source on GitHub, and it also doesn't actually need Steam. So Valve, of course, makes Steam. So you might think that they only want to enforce this for like Steam games, but it works with both Steam and completely outside of Steam. Obviously, we are not using Steam at the moment inside Hazel with the demo that I showed you, and everything is working. So it's a really, really nice library. It's quite popular as well. It kind of combines the best of TCP and UDP because obviously you want this to be performant and work well for game engines and games. Anyway, I'm not going to talk too much about this. I actually kind of covered this a little bit as part of Walnut Networking because funnily enough, Walnut Networking is basically what you see here inside Hazel. I basically stole Hazel's networking implementation, which uses Valve's Game Networking Sockets, from Walnut, my own library. So Walnut Networking is open source. You can see over here, this repository is public. If you go into source Walnut Networking, you'll see the same 6 files. Now they've been adapted to Hazel a little bit differently. You can see this namespace, for example, is HazelNet, and over here it would be Walnut. And I probably have maybe fixed some bugs or added some features, but if you want to take a look at Hazel's kind of networking API, then it is actually open source as part of Walnut. I'll leave that repository in the description below as well. Anyway, all of that aside, let me take you through the API. So I guess we'll start with the server. So the idea is you need something to run a server. Typically, you would make an actual application that is the server. So if we take a look at HazelNet, this is the net branch of the Hazel repository. I should probably also mention that for those of you who do have access to Hazel via patreon.com/thecherno for $10 a month, thank you for helping to support the project. Over here on the Hazel repository, which you get access to instantly when you support the project, you'll see there is a net branch. And so this net branch, that's what I'm showing over here. So the other branches are quite different because they have no networking functionality. Obviously, this will be eventually merged into like the main branch. But over here inside the net branch, we actually have a few different solutions. We've got Hazel, Hazel Client, Hazel Headless, and Hazel Server. Hazel Headless you don't really need to worry about, and Hazel just combines everything. So Hazel Client and Hazel Server are the 2 solutions that I generally use. I've been inside the client one, but if we open up the server one, this is probably a little bit better to look at since we're discussing the server. You'll see this project over here under the net folder called Hazel Server, which we didn't see in that other solution. And that has some other stuff here, but the actual core networking API is still inside this HazelNet module. So this is its own project. I'm going to try and run it now. I don't think I really ran it this year. It still works though, which is great. And so you can see this is the GUI version of the server. So we have the headless version, which is running on Linux over here. And obviously this is also compiled on Linux. This is compiled on Windows, obviously. And you can run this as a GUI, or server as a headless server as well. So we can run this within like terminal command prompt as a console application. But this is the GUI version, which might be nice if you want to like see some more information visually, like the clients that are connected. And you can also send messages. I mean, you can do that through the command line, obviously, as well. But anyway, I made two versions. GUI version. The GUI version, I think, also does work on Linux, because when I was working on Hazel server on Linux, because I needed to get it compiling on Linux to actually deploy it onto a proper VPS like this, I think I started with probably the GUI one, which works because Hazel works on Linux, and then I did the headless build. Anyway, most of the code inside Hazel server is for actually running Hazel itself. So it's not really server specific per se, but we still need to do things like open the project, do basically all of the game engine things that you would do, just not the rendering. And the reason why is because we still want the entire game engine to like run in the server, because in most multiplayer games, you need the server to be the authority for everything that happens like in the scene, in the gameplay that is happening, because you obviously can't trust the clients, because any client could just modify itself and then do whatever it wants to. So for example, something seemingly as simple as just those females at the start moving randomly, the server needs to be the one to spawn them, obviously tell all the clients that, hey, there is an entity here at this location, it's moving around like this. But then how do you handle things like collision? Oh, well, you need the physics system, and the server needs to be aware of all of the players, all of the kind of collidable objects, like the terrain, the map, all of that stuff, so that it can actually do that physics simulation, and then just tell all the clients that's what's happening. Whenever the player moves and it needs to do a physics simulation, it could just hack itself to go through walls, for example. So the server needs to actually do that simulation as well, and then be like, yeah, that's legit, like the client has moved into a plausible location, so we can now transmit that to all the other clients. You basically need to run the entire game on the server, just minus the rendering. Typically, you might actually want to keep the rendering if you want to be able to observe things as a server itself, although typically you would just connect as like a client and then be able to inspect it. So we don't actually do any rendering really as part of the server. At least Hazel doesn't do its normal scene rendering. We do like the IMGUI rendering, the UI rendering you saw for the GUI version of the server. Anyway, that's why this is a little bit complicated, because it's not just as simple as the server receiving data and then reformatting it or whatever and then transmitting it to all the other clients. It actually has to play the game itself. So that's what most of this stuff that you see here is. As far as the actual API goes, it is dead simple, but it's also up to the game to actually control how the server gets started, and if it gets started, and how that works, what it does with data that it receives, and also the client side of things. So connecting to a server, sending data to a server, none of that stuff is actually controlled in the C++ code. We just make an API, we make it available, and then it's up to the game to use that API to kind of pull the puppet strings to make multiplayer happen. So we provide quite a primitive set of tools. You can see here that in client, for example, the API, it's just got the ability to connect to a server, to disconnect, and then we can set these like data received callbacks, so we can respond to ourselves receiving data or connecting to a server, disconnecting from a server, and then we have an API to be able to send data, just as binary data or strings. That's basically it. And then from the server's API, it's basically got the same thing. You create the server object, you start it with a particular port, and then you can set these like data received, client connected, client disconnected, all of these callbacks to respond to certain events, as well as send data. And then you've got some other utilities like being able to kick clients. And then these clients will persist inside this connected clients map. And that is because Valve's game networking sockets library actually maintains persistent connections. So really it's doing all of the heavy lifting. We're just providing an API for this inside Hazel, as well as managing like the connections to some degree in a way that games might want to utilize this functionality. And that really was my goal with this, because I, first of all, don't have enough experience in networking and multiplayer to make really strong design decisions, to kind of try and shape a path that is somehow going to suit all kinds of games that people might want to make, even games that I wanted to make. Like, I really didn't feel comfortable trying to design this kind of, okay, this is how multiplayer games work in Hazel. You just multiplayer equals true, then suddenly entities will synchronize magically between the client and the server. No, none of that stuff was, first of all, even appealing to me. Like, I don't think I would want to make a multiplayer game that just automatically somehow works behind the scenes and then realize that, oh, actually, this isn't going to work, or I want to do this extra thing that's not supported. But then the other side of this coin here is that it would be a lot of work to do something like that. So apart from this, like, trying to design this blind, which is not a great idea, it was also, that's going to take a significant amount of resources. And I mean, the first real game that I personally want to make with Hazel, like proper premium game, that's not even multiplayer. That's not, I don't really want to make a multiplayer game. So I don't want to say that multiplayer is like this afterthought inside Hazel. I just wanted Hazel to be able to have networking functionality so that you could theoretically make multiplayer games, but I didn't want to go too hard on locking in some kind of design that all users would then have to adhere to. This does obviously slightly complicate things for games, because they then have to implement the actual multiplayer design, you could say, themselves. However, it also gives them the freedom to kind of build their own architecture on top of Hazel that just uses this low-level API, well, relatively low-level API, and that obviously gives the games a lot of flexibility. And that's not to say that Hazel isn't even aware that it has multiplayer. Of course it is. So for example, in this editor scene that we were looking at, if we click on
I finally got a job. Now I can finally afford to sub. Wait, is that the secret? I just got to get you all jobs, and then the subs will roll in? What do you think the easiest job in tech is? That's all changing now. I feel like the easiest job in tech before, well, I'm biased. I see more of the marketing side. Product manager was a pretty easy job. I'll be honest with you, bro. Product, not project. Product manager was pretty fucking easy, dude. But here's what I was gonna say. In my experience, product marketer. Let's do a little explanation, because maybe you don't didn't work in Silicon Valley. You don't give a shit. Product is kind of
You know, how difficult can it be? Mm, mm. Advanced Engineering Mathematics 10. I think that's the same I have. Okay. So this was... I guess we can read 61 to 6.1 to 6.6 today. Maybe. Product different, what? Um... Damn, I'm not... Okay. Laplace transforms are invaluable for many engineering mathematics textbooks as they make solving linear or ordinary differential equations and related initial value problems, as well as system of linear ODEs much easier. Ordinary differential applications, bound electrical networks, spring mixing problems, signal processing, and other areas of engineering physics. The process of solving an ordinary differential equation using Laplace transform method consists of 3 steps shown schematically in figure 1.13. Step 1, the given ordinary differential equation is transformed into an algebraic equation. We'll just the given ordinary differential equation is transformed into an algebraic equation called the subsidiary equation. The subsidiary equation is solved by purely algebraic manipulation. The solution in step 2 is transformed back, resulting in a solution of the given problem. The key motivation for learning about Laplace transform is that the process of solving the ODE is simplified to an algebraic problem. This type of mathematics that converts problems of calculus to algebraic problems is known as operational calculus. The Laplace transform method has 2 main advantages over the methods discussed in chapter 1 to 4. One, problems are solved more directly. Initial value problems are solved without first determining a general solution. Non-homogeneous ODEs are solved without first solving the corresponding homogeneous ODE. Okay, so then the general solution, I guess. More importantly, the use of a unit step function, heavy net function, or Dirac delta is a method particularly powerful for problems with inputs, driving forces that are discontinuities or represent short impulses or complicated periodic functions. The following chart shows where the fields where to find information on the Laplace where to find information about the Laplace transform in this book. ODEs are in this chapter. I think PDEs, is that like periodic differential? I guess. No, partial. List of general formulas. Oh, we can look at that later. Ticket solutions. That's nice. This is Laplace transform and inverse. Your CAS calculator can handle most Laplace transforms. Laplace transform linearity first shifting theorem as shifting. This section will learn about Laplace transforms and some of their properties. Because Laplace transforms are of basic importance to the engineer, the student should pay close attention to this material. Applications to orthogonal differential equations follow in the next section. Roughly speaking, the Laplace transform, when applied to a function, changes that function into a new function by using a process that involves integration. Details are as follows. If f of t is a function defined for all t greater or equal than 0, its Laplace transform is the integral of f of t times e of st from t equals 0 to infinity. This is a function of s. Say big F of s. This is denoted by Laplace transform of f thus of f. Okay. Here we must assume that f of t is such that the integral exists. That is, has some finite value. This assumption is usually satisfied in applications. We shall discuss this near the end of the section. Not only the result f of s is called the Laplace transform, but the operation just described, which yields f of s from a given f of t, is also called a Laplace transform. It is an integral transform. It is an integral transform with kernel k of s of t equal to e of s of t. What is a kernel transform? Not only is the result of f of s called the Laplace transform, but the operation just described, which yields f of s from a given f of t, is also called the Laplace transform. Okay, so the transformation is also called a Laplace transform. Okay, I guess. This is an integral transform f of s with kernel. Note that the Laplace transform is called an integral transform because it transforms a function in one space to a function in another space by the process of integration that involves a kernel. The kernel or kernel function is a function of the variables in the two spaces defined in the integral. Lite grann salt. Not that the Laplace transform is called an integral transform because it transforms a function in one space to a function in another space by process of integration that involves a kernel. The kernel or kernel function is a function of the variables in the two spaces and defines the integral transformation. Furthermore, the given function f of t in 1 is called the inverse transform of f of s is denoted by, that is, we shall write, okay. Note that 1 and 1 start together imply f and f. Wait, I think that's just a solution to this. Not that. This. I think this, yeah. So basically we want some I think we want to prove that this is equal to this is equal to this. Maybe. Notation. Original functions depend on t and then transform on s. Keep this in mind. Original functions depend on t. Original functions are denoted by lowercase letters and their transforms in their letters in capital. So that f of s denotes the transform of t. Laplace transform. I guess we try. Okay. We have some L of f. I guess we use our notation. Let f of t equal to 1. Okay. Find what is the integral from 0 to infinity of e of minus st f of t dt, where t is equal to no. Okay. What did we do here? Did we say that this is just minus f of st minus s f of s? No. Okay, let's see. Okay, they just set f of t to 1. Um, Yes, rules. Oh no shit. Straight in, straight out. Okay. Um, 0, 0, infinity, infinity. Okay. E to the minus, no, e to the u, 1 over minus st u. This is e to the u, so we have 1 over s, e to the, I guess we call it dice, 0. Oh yeah, okay. Then u is minus st. This is 1 minus, this goes towards 0. Okay. Such an integral is called an improper integral and, by definition, is evaluated according to the rule. Hence our convention convenient notation means it means that this becomes the limit t as t from 0 to t. Okay. Okay, so this will be f of s is Laplace transform of f of t. E minus st e a t dt e t a minus s dt 1 over a minus s e that's u. Yes. Et minus a minus s evaluated from 0 to infinity. I wonder if you need this. Always. Then we have some borders here. So here we have e infinity a minus s over a minus s minus e 0 over a minus s. This here goes to 1 over a minus s. Okay. I guess this depends. So this would be e. This would be limit t goes towards infinity, no? Right. Yeah. Of this. This will be infinity when A is greater than S. I guess this is infinity minus 1 over A minus S when A is greater than S. So we're equal 1 over 0 when A is equal to S. This would converge to 0. This is minus 1 over A minus S when S is greater than A. I guess this would be the answer. When S minus A is greater than 0, which is true when S is greater than A, we have 1 over S minus A. Which is the same. Okay. You don't need the rest. I guess not. Okay. How many factors? Damn. Oh, this is gonna take a while. Okay, we have all day. Let's see here, 30 minutes. 1, 2, 3 papers. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Damn. So this is 6 per hour times 30. Really? What factor is this? I guess we go per minute times, no, per hour. This can't be correct, can it? No, 6 per hour. How many hours to get 30? So 30 divided by this. 5 hours, okay. Must we go in this fashion and obtain the transformation of one function after another directly from the definition? No, we can obtain the transformations from known ones by the use of the many general properties of the Laplace transform. Above all, the Laplace transform is a linear operation, just as are differentiation and integration. By this we mean the following. Laplace and Laplace transform. We have the linearity proof here. The Laplace transform is a linear operation, that is, for any function f of t and g of t whose transform exist and are constants a and b. The transform a times f of t plus b times g of t exist, and the Laplace transform of the sum is the Laplace transform of each of them summed. This is true because integration is a linear operation, so that 1 gives... Jesus Christ. I guess you need to prove the other way, maybe. Application of theory in a hyperbolic function. Find the transforms of cosinus hyperbolicus of a of t and sinus hyperbolicus of a of t. Since cosinus hyperbolicus of a of t is why do you know that? Maybe that's just known or something. Let's see here. General. Specific. Given function cosinus hyperbolicus of a of t, we have s over s squared minus a squared. We just got a solution. Linear to s shifting. Let's see. Wait, no, that's just a general rule, I think. We obtained from example 2 and theorem 1. Theorem 1 is the linearity. We should try it ourselves, I think. Okay. I guess what's better here is to go minus t s minus, no, yes, yeah. This will be 1/2. This here will be times, okay, I guess we go 1 over s minus a. Right, since we have no, do we? Minus t both 0, 0. It's correct so far. I don't see how they get the next step. Huh. I guess there might be some like 1 over 2 s minus a plus 1 over 2a plus s. Cross multiply, we have 2a plus s plus 2s minus a over 2s minus a 2a plus s. This is 2a minus 4, 2a minus 2a, 2s plus 2s. So this is 4s over 2s times, I guess, 4s times a minus sa S times A, S times S. A times A minus A squared. S over S squared minus A squared. Okay, I think that's correct. Yeah, okay. Okay, cosinus and sinus. Try the formula. Holy shit. This one's just... they keep getting harder. Laplace of cos. Wait, so wait. Integration by parts to take this time. Okay. The root of this times this. Integral of this times this. Why is there this there? The plans. Sorry, I was at the toilet. Maybe for your, I think next week maybe. Yeah. Fuck. No, I should stop the negative self-talk. I can do this. Come on. There's a weird S though in this. Integration by parts. Like integration by parts is I think we have some. No. This is derivation by parts. What the fuck is integration by parts? Oh, it's this one. Oh, fuck. Yeah, this general formula. Damn. Okay, I know about it. I don't think it. Okay. By substituting the Laplace transform of sinus into the formula for the Laplace transform of cosinus. Whoa. Oh. I see, okay. On the right side, and then by substituting, we obtain Laplace transform of cosinus. Time. That was solved for 1 over S factor out Laplace, and then. Okay. Damn. How would you? My bad. We're doing Laplace transforms. I'm doing Fourier series next week, I think. Yeah. Or technically this week. And I'm finishing up. I'm a bit sick, sorry. Oh, my bad. No worries. I don't know what convolution is. Damn, it's gonna be a rough year. Fuck. I don't know how I would have gotten this myself. The Laplace transform of cosinus or sinus. That's difficult. Since you basically you do the transform of both, right? Apparently. And you get some factor with the other. And then you solve this linear system to get the individual parts. No, you don't. Yes, you do. Yes, you do. Yeah. I've never seen like this way of doing it before. Okay. Well, okay, now I've seen it at least now, so maybe it's easier going forward. Okay. Basic transforms are listed in the table. We shall see that from these almost all others can be obtained by using general properties of the Laplace transform. Formulas 1 to 3 are special cases of Formula 4. Where are the formulas numbered? They are not numbered. Oh, in this table. Okay. Wait, let's see. Formulas 1 to 3 are special cases of formula 4. I agree. Which is provided by induction. Indeed, it is true for n equals 0 because of example 1 and yes. We make an induction hypothesis that it holds for any integer larger than 0 and then get it for n plus 1 directly from 1. Indeed, integration by parts first gives Laplace transform. Okay, we can work through this, I guess. Laplace transform of t n plus 1. This would be I don't know if we did this. Yeah, this was the formula. Okay. This is an induction. This is the integration by parts here. Fuck. Okay, I'm not gonna do this. I see. Oh, this is horrible. Maybe it's not. Is the derivative of t n plus 1 with respect to t? Oh. Okay, so it is horrible. Wait. Yeah, I need to do the whole integration by parts. You know what? I'm gonna trust the book. The book might be correct. Now the integral free part is 0 and the last part is n plus 1 over s times the Laplace transform of t to the nth. From this and the deduction hypothesis this plus the general formula, and then you rewrite that to n plus 1. No, we do not. No, yes, you do. Okay. S times S. Yes, okay. Let's prove Formula 1. Okay, this is difficult. Did I skip a page? Okay, so 5t to a number a is what that thing does. What is what is the symbol used in my engineering text book that looks like a large T but without the left hand side of the top line? I guess I could have searched like this. It's this one, gamma. No. This is fundamental extension of the factorial function to a complex number. While you might see it more in pure maths or advanced physics, it has applications in engineering, statistics, and certain transform methods. For a positive integer n, I guess gamma of n is n minus 1. What do you call a float in mathematics? That's a real number, I think. What if it... I think it's the gamma function. It is used with is it like BBM? No, BBB? R? I think I'm like math. I think I made my own actually. Let's see here. Yes. BBBR. Yes. So this is the gamma. Okay, we can write out the formula. So this will be gamma. This would be frac gamma a plus 1 over this is exponential. I think we just go s to the a plus 1 such that this is the formula. Oh, it fucking says it right here. Gamma a plus 1 is the formula, is the so-called gamma function. We get formula 5 from setting st equals to x. What the fuck? Where's this? Damn, I need to find no nasal spray. I can look. Maybe I haven't. Maybe that helps. Section 5.5 or 24. What do you mean 5.5? Interesting. I'm not gonna lie, I lost a plot here. Okay, T of A, where A is any positive number. I guess the gamma function lets us use a factorial, but for any real number. So T of A, blah blah blah. Let's see here. What the fuck? I set x as t to x. Okay. We obtain. Yes. I don't see it. I don't see it. As a times some s somewhere. Yes. E to the minus x times a dx. Yes. Where s is greater than 0. Last integral is precisely that defining the gamma a plus 1. So we have as claimed quotient a plus 1 has x to the a. The integral not x a plus 1 note the formula 4 also follows from 5 because oh my god. Okay, you know what? Timer for a minute and then we take a break. Note the formula 4 also follows from 5 because putting samples to the 4. Okay. The 11 and 12 will follow from 7 and 8 by shifting to which we turn next. 8 equals to 50. to S, you just swap with S minus A. That doesn't seem too difficult. Yes, I guess. Yeah. The Laplace transform has the very useful property that if we know the transform of f of t, we can immediately get that of e to the a of t f of t as follows. If f of t has the transform f of s, where s is greater than k for some k, then e of a of t f of t has the transform f of s minus a. Ooh, that just went right through my head. If it has a transform f of s where s is greater than k for some k. I guess that means like there exists some k which is a bound. Then e to the at f of t has a transform f s minus a. S minus a is greater than k from s. Replacing s with s minus a. Fair if this it's interesting. Okay, we can try that. Okay, so we're tasked with finding the inverse of the Laplace transform of f with respect to t. I think this would imply this here would be f, so this is the inverse of the Laplace transform of f, big F, which will be What the fuck? Okay. It's given. Plus transform. F is equal to f of s is 3s minus 137 over s squared plus 2s plus 401. And they're asking us to use the previous formulas to find the inverse of the transform. I don't really want to do this. Okay, we'll take a short break. I miss when I made songs like this. It's so fucking good, you know? Probably the most underrated song of all time. It's so fucking good. Holy shit.
Chains are keeping quiet secrets. Look out, but the poison's running through you. My stomach aches. Hear the bells. Hear the bells.
The 2010 is over. Show, but people like music. Right. Okay, I need to take a piss and then grab some more coffee and then we continue. Do 1 hour. You know, 50 minutes. 50 minutes, good. Okay, with some S shifting, I didn't understand how to solve this thing. Okay, factor out the what the fuck? Okay, you say s is s plus 1. For some reason, you shift it once to the... Oh. Oh. Whoa. Whoa. What the fuck? Can I do that? How the fuck would it think of that? Wait, what? What? Okay. So for 3s minus 137, they rewrote this as -3 minus 140 plus, it should be plus, right? Yeah, it's plus. So then they get 3s plus 3 minus 140, and then this they factored 3s plus 1 minus 140. Okay. Now for this bottom part, they did something similar. They did s squared plus 2s plus 401. Let's see if we can figure this out without looking. Okay, what do we want? We want to get s plus 1 somewhere. Okay, here we have s plus 2 plus 401. Which isn't quite what we want. I guess we try to rewrite this as s squared plus 2s plus 1 plus 400. And then this we factor to be s plus 1, s plus 1 plus 400. I think so, yeah. So then we get this first thing will be 3s plus 1 minus 140 over s plus 1 squared plus 400. Right? Yes. Oh, what the fuck? S plus. Okay, and the next step I do, what? They are doing something with the tree here. 400 minus this 360. You factor out 20 squared. Isn't that just 400? Okay, I don't see what they've done here. S minus A. Oh, they split it. Okay. Okay, I see. Okay. 7 times. Okay. Damn. Okay. I wonder how I would have done this without help. Okay. So they split it there. So we get 3 s plus 1 over s plus 1 squared plus 20 squared minus 7 times what's that? 20 over s plus 1 squared. Okay. And then these ones are just the formula for sine and cosine, right? S minus A S minus A. It should be plus. What? It's the inverse transform, probably. There's so much work, holy shit. Okay, so that is A equal to 1. A is e to the minus t. 1 minus a is a, plus 1 will then be minus 1, which is just t. Okay. I guess we say that this one is equal to plus 1. Omega is equal to 20, yes. So then the formula E minus AT no EAT cosinus omega t. This is the Laplace transform, is equal to S minus A over S minus A squared plus omega squared, such that no, yes, omega can just be 20. And A has to be minus 1. This implies that the inverse of this will be E minus t cosinus of 20t. I think, right? And then times 3 minus omega will be top and A will be plus 1 minus 1 such that we get E minus T sin of omega, which is 20 T times 7. E minus T 3 cosinus 20 T minus 7 minus 20 T. Jesus Christ. Damn. Absorb it, brain. Come on. Put it in your head. We now see that the inverse of the right side is the damped vibration. I don't even know what that means in this context. Existence of uniqueness of Laplace transforms. This is not a big practical problem because in most cases we can check the solution of an ordinary differential equation without too much trouble. Nevertheless, we should be aware of some basic facts. A function f of t has a Laplace transform if it does not grow too fast, say if for all positive t and some constant m and k it satisfies the growth restriction. That's about it has to grow slower than okay. F of t need to be continuous, but it should not be too bad. But it should not be too bad. The technical term generally used in mathematics is piecewise continuity. F of t is piecewise continuous on a finite interval t is between a and b, where f is defined. If the interval can be divided into finitely many subintervals, in each of which f is continuous and has finite limits as t approaches either endpoints of such a subinterval from the interior, then this then gives finite jumps as in 115. So only possible discontinuities, but this suffices in most applications, and so does the following theorem. If f of t is defined and piecewise continuous on every finite interval on the semi-axis t greater than 0 and satisfies 2 for what was 2 satisfies 2 that's formula for all t positive t and some constants m and k, then the Laplace transform exists for all. If f of t is defined and piecewise continuous on every finite interval on the semi-axis and satisfies for all positive t, then the Laplace transform exists for all s and k. Since f is piecewise continuous, E of s EF minus ST, f of t is integrable over any finite interval on the t-axis. For two. This feels wrong. I'm not reading it as this anymore. This one is definitely wrong. It's basically this question here, right? Find the transform. Show the details of your work. Assume that A, B, omega, and theta are constants. there's no real example of a graph solution or a solution to a graph problem here. I don't really know what to do. There's nowhere in the previous chapter either, apparently. Yeah. I don't know. Guess we take a note. 24. Right. Prove that the inverse transformation is linear. Okay. La f av t og g av t da a f av s og b g av s være plass transformasjoner av f av t og g av t. Da har vi at plass inversen av a f s pluss b g s er lik a plass inversen av f av s pluss b plass inversen av g. Må være a plass inversen av e minus st f av t. Nei. F av s. Pluss b plass inversen av e minus st g av s. Som selvfølgelig er a f av t pluss b f av t. Nei. Dette er integraler fra 0 til 0 av den. Pluss integraler. Nei. Som selvfølgelig er A av Laplace invers av F. Nei. Blir det feil, Norge? Hva skal vi vise? Prove that is linear. The inverse transformation is linear. Hint. It's shifting. Okay, this no. This is the integral from 0 to infinity. Let's just double check that. The inverse, how is the inverse Laplace transform defined? Is it not just this? Just want to see an example. The inverse Laplace transform will be EAT of S. Okay. So the inverse of this will be E A T piece of shit. There's like S shifting proofs. Oh, okay, maybe we can just go. I don't think we need this done either. Maybe we can just go. How did that work? Laplace transform of F plus G. Okay, I know what to do. We say this is equal to, no, we can't do that. I wanted to basically write, or split it already, right? So we have A, F, S, plus this, but we can't do that because we haven't proven that yet. I guess we could say that this is equal to, What's that say? C plus K infinity. I don't think that's the way. I think we might be able to just use the fact that this is given with the normal Laplace transformation. So then we have a Laplace minus of f of s plus b plus c g of s. I guess this, right? Maybe. I don't know, this is difficult. I don't know. I guess we can search. We're basically proving this theorem, right? Inverse Laplace transform Then Google is often way better. Will this load or? Oh, that's nice. So this is the definition of the inverse Laplace transform. Y is provided that f of s is prove which integral, but I want to know how the expression is derived. I can find any. So we're basically looking for this thing, but it doesn't say it in my book, so I'm assuming I don't need to use it. I don't know. I think it's fine. I guess we can. Do we have some proofs, sir? Uh, in a common special case where all singularities satisfy. Yes. In these cases, the image of the Laplace transform lives in the space of analytic functions. In the region of convergence, the inverse Laplace transform is given by the following complex integral, which is known by various names. The Bromwich integral, Fourier Mellin integral, and Mellin's inverse form, where gamma is a real number, so that the contour path of the integral of the integration is the region of convergence of f of s. Okay. 32. Right. Yeah. Given the Laplace transform of f, find f of t. F of s is equal to Laplace transform of f which is given to us as 1 over s plus a s plus b. We need to find okay, so we go like it in in f of t. Okay, so we can take the inverse of this. So this will be Let's see here. This will be the inverse Laplace transform of f, which will be the inverse Laplace transform of 1 over s plus a, s plus b. Is this Delbrücks och Svalberg? It could be. They might want us to. How else would we do this? I can check the table, I guess. So f of t given as s plus a, s plus b, s minus a, s minus b. Okay, so we don't have a table for it, I don't think. So this would be let me see. The inverse we find a and b. Table? I'm so fucking poor. Holy shit. I'm kind of struggling, not gonna lie. What the fuck? What's up? Peismann H? What the fuck? Vänta, vänta. Um. How would you solve this? I guess what's okay. We're doing this one here. I guess we're sort of asking by what transform do we end up at this? Have you seen something similar before? I guess if we like guess. No. STEAT. This would be transformed to, let's see here. This can just be written as E minus T S minus A. So we start on a plus 1. So if we say this is minus A, instead we get plus, which means we get 1 over S plus A. If we just guess that maybe if we add another minus B here, could this work? No, it wouldn't, because that would just be B here. Which then would just be plus B. Okay, so this thing would be S squared plus SA plus SB plus B. No, AB. I guess that is the way to do this, actually. No, it's not. Is it? I don't think it is. I guess, okay, what do we look at the solution for a different problem? But there's no solution for a different problem here. Fuck. I don't know how to do this. I don't know how to do this. We did, okay. This is fucking difficult. we need to find a way, right, to write this as a table, one of the fractions on the table. I think. So this would mean okay. Vi ser I tabellen over inverse transformasjoner og finner if we set A and B equal to each other, we have something that looks promising. Let's miss all that back. How difficult can it be, you know? How do we split up this piece of shit? Okay, we have a couple of ways, I believe. We could multiply it out, of course, so then we get s squared plus a 2ab, no, s times b, s times a, s b, a b. So then we can look for this 1 over, right? Let's do an example. probably a bit loud. A similar one. That I'm thinking about using. If s is equal to 1. Huh. This one looks promising as fuck. A minus B. Okay, so if we say we rewrite this, so it will be S minus A, S minus B. I think this works. Yes, okay. Okay. Og finner 1 over S minus A, S minus B is equal to when A does not equal B is equal to, I guess we go like this, 1 over A minus B EAT minus EBT when A does not equal B. Det vil si at en over S minus minus A, S minus minus B, Laplace invers til 1 over minus A minus minus B, E minus AT minus E minus BT når A ikke er lik B. Som da er 1 over B minus A E minus AT minus E minus BT. higher solutions in the book. So it's odd numbers, 32 is even, so there wouldn't be a solution. Fuck. I'm not how I would know if this is even correct. I guess we'll just move on. Hope it's correct. 33. We can see with 33 though. Oh, it's a different type. Okay, fuck. Okay. Up. Go over. Find transform. Find inverse. 33. In Laplace transform of f of t når f of t ner til å være Oh, fuck. This is partial... No, integration by parts, I think. I'm pretty sure. Yeah. Okay, then we get... of E minus ST times T to the 3 E minus 2T dt. This can be written as integral of 0 to infinity E minus T s plus 2 T cubed dt. Okay, so okay. We'll probably read through this. I believe you say which when derived will be what, and which is easy to derive. So basically, I think we set u to be e minus ts plus 2 and dv to be t3, no, 1/3 t. Where? Okay, we should probably write. It's a simple matter to take the derivative of the integral using the product rule, but there is no product rule for integrals. However, the section introduces integration by parts, a method of integration that is based on the product rule for derivatives. It will enable us to evaluate this integral. The product rule says that if u and v are functions of x, then the derivative of uv is, though, for simplicity, written u and u of x and v of v of x. Suppose we integrate both with respect to x. We get this. By the fundamental theorem of calculus, the left side integrates to uv. The right side can be broken up to two integrals, and we have so the second integral we have you move this over, or this over. Using differential notation, we can write du, the derivative of u dx, and the expression above is as follows. Let u and v be differentiable functions and x on an interval I containing a and b then. Let's try an example. Solution. The key to integrate by parts is to identify parts of the integrand as u and parts as dv. Regular practice would help one make good identifications, and later we will introduce some principles that help. For now, let u equals to x and dv equals to cosine of x. So what's easy to integrate? Whoa. Okay, we go like this. La u be equal to t, dv will be e minus t s plus 1, 2. du becomes 3t squared. d t. So this will be the derivative of u and the derivative of x. What if I take the derivative of will become this? Maybe we should have done the other way. Okay, v will be 1 over s plus 2 e minus t s plus 2. Right? So let this be u. This will be minus u, or minus the derivative of u with respect to t. So this is s plus 2. Yeah. Okay. So now this. Cosmos. Since dv is cosmos. Is equal to sine. This is the original. Integration by parts. We have uv t cubed 1 over s plus 2 e minus t s plus 2 minus the integral 0 to infinity of v. There's no this is easier, no? I know that it won't even fit on the page. Okay. They let u be x. And v be sinus of x such that dv equals cosinus of x. Yes. God damn, I'm struggling big time. Holy shit. I guess we're just trying. V du. Well, surprise, surprise, this shit doesn't help me. Okay, I guess We can try the opposite. If we let u be e minus t s plus 2, dv be dt, then v will be 1/4 t to the 4, and du will be fucking piece of shit. I don't know. It's just a mental battle, you know? Maybe it's not integration by parts, you know? I guess if the T disappears here, it will work. Okay. It's here. dx of e to the ax. Okay. dx of e to the ax. I'm guessing this would be true for minus as well. Yes. No, wait. No? Okay, so that would mean we won't get rid of the t. So this is not solvable by different parts. I don't think. Okay, it does say S shifting. There's something here, you know? If we can basically S shift this thing to something like this thing, then we can solve it. um, how, I'm not sure. Since we're saying if f has some transformation, then a of t, f of t has to transform if we say that this is f, some f that we know an answer for, then we say that this is a. Okay, I think I see this assumption. Okay. Okay, I think we're gonna call it there. I think I will be able to solve this though. There.